Chapter 3.1, Exponential Functions and their Graphs. So we want to recognize and evaluate exponential functions with base A, graph exponential functions and use a one-to-one property, recognize, evaluate, and graph exponential functions with base E, and use exponential functions to model and solve real-life problems. So just some basic information about exponential functions, just for FYI. Exponential functions and logarithmic functions are two types of non-algebraic functions. These functions are actually examples of what's called transcendental functions. A definition of exponential function is that the exponential function f with base a is denoted by f of x equals a to the x. A has to be greater than 0, and a can't be 1. And x is any real number. So just note that the base cannot be negative. The base a of an exponential function cannot be 1 because a equals 1, yields 1 to the x, and so therefore this is a constant function. It's not an exponential function. Let's evaluate exponential functions. So basically this is just plugging it into a calculator. Use a calculator to evaluate each function at the given value of x. So to do these problems, you just have to plug it into your calculator. Now if you're using the one that is approved for class, the TI-30X2S, then you would type this in. You would type in 2 and then use the caret and then the negative sign, which is at the bottom right corner. It looks like a negative with parentheses around it. Don't use a regular minus sign, that won't work. And then 3.1. And then when you do that, and then press enter, you will get 0.1166291. So 7 decimal places is what the book has. So it was just a matter of practicing plugging this all in. Go ahead and try it. Plug in B, C, and then the one below. Just plug it into your calculator. And when you come back, I'll have the answers for you. All right, so if you tried this out, you would have gotten these answers here. So just make sure you are adding the correct parentheses where you need it. So for example, especially this one, when you plug it in, you want to have it 0.6 caret and then parentheses 3 divided by 2 and then equals, and then that should work. And then, same thing for this one below. You would type in 8 caret, the negative sign, and then the square root of 2. So hopefully that helps out. Let's go ahead and try the next piece. Let's look at graphs of y equals a to the x. So in the same coordinate plane, we're going to sketch 2 to the x and 4 to the x. So we're just going to pick a couple of points to graph. And so we want to think about, what are good values to choose for 2 to the x. And one that you should always choose is 0. Because 2 to the 0 is 1. Then we'll choose 1, that is 2. If you choose 2, that's 4. If you choose negative 1, so remember that's 2 to the negative 1, that is 1/2. So if I just plot these points, it's at 0, 1, and then 1, 2, and 2, 4. And then at negative 1, we're at a half. Okay, so this is the graph. It has a horizontal asymptote at y equals x here. Now we'll do 4 to the x as well. And so again, you just choose some good points to plug in. So x, y, we choose 0, 1, and 2, and negative 1. And so we plug in 1, we get 4. Plug in 2, we get 16. At negative 1, we get 1/4. So it's still at 0, 1. Then we have 1, 4, and then 2, 16, which is off the graph. And then now we get a 4th. And so here is the graph. So you can go ahead and try that for 3 to the x and 9 to the x. So pause the video, and when you come back, I'll have the graph for you. Okay, if you tried this out, this is what you would have gotten. So I hope that helps. Let's try to take a look at graphing y equals a to the x. So we're going to sketch 2 to the negative x and then 4 to the negative x. And so again, we pick values to graph. And so I'm going to choose negative 2, negative 1, 0, and a positive 1 here. And then for our 4x, we'll do the same thing. So we will choose negative 2, negative 1, 0, and 1. So for 2 to the negative x, that's still 1 at 0. And then when I plug in 1, I get a half. At negative 1, I get 2. And negative 2, I get 4. And then for the 4 to the negative x, I get 1, 1/4. And this is 4 and 16. So let's graph it. We get 0, 1, and then now I go left 1, and then I'm up at 2. And then at negative 2, I'm at positive 4. And then at positive 1, I am at a half. So notice that it flips over the y-axis. And it's a decreasing function at this point. Then we have the same thing with the 4. Okay, and so we still have a horizontal asymptote at that same spot. Okay, and so you can graph this one 3 to the negative x, 9 to the negative x as well. Note that it is possible to use one of the properties of exponents to rewrite the functions with positive exponents. So for example, you have 2 to the negative x, you can rewrite as 1 over 2 to the x, and it's the same thing. Okay, so pause the video, I'll draw this one out, and then you can check. All right, so if you tried this out, you would have gotten these two graphs with these values here. And so hopefully you're comfortable with plugging these in. Like, for example, if I plugged in a negative 1, it would become a positive 1, and that's where you get a positive 3. Okay, so just real quick, some basic characteristics of an exponential. So when a is greater than 1, and then also when the exponent is positive, the range is, or the domain is negative infinity to infinity. Okay, it always intersects at 0, 1. Our range is from 0 to infinity. Our y-intercept is 0, 1. It is always increasing. We have a horizontal asymptote on the x-axis. It's a continuous function. And then another thing I want to mention is that as a to the x approaches 0, a to the x approaches 0 as x approaches negative infinity, right? As it approaches negative infinity, the function approaches 0. Then if the exponent is negative, the domain is still the same. The range is also still the same. The y-intercept is still at 0, 1. So graphing that here, it's at 0, 1. But instead now it is decreasing. Okay, it's decreasing. The horizontal asymptote is still on that x-axis, and it's a continuous function. Now instead, our a to the x approaches 0 at what point? Well, it approaches as x approaches positive infinity. Okay, so I hope this helps. Thanks for watching.